Okay, so in this video, we're going to go through a couple of examples from the 1.1 homework. So we're going to start with number 15. There's of course lots of problems before this, but I feel like with the concepts video, you should be able to tackle those ones just fine. If not, we're going to go through some of those same concepts in this problem, so you can watch this one and then go back and see if that helps you with the previous problems. The reason why I selected this one, though, is usually with the problem gives you a graph to look at. But in this one, we have to graph it ourselves. So I just wanted to help you through that process, and then we can talk about some of the limits. So if I look at this, so here's my function, right? I've got g of x is equal to 3 over x plus 6. Well, even before I start analyzing the graphs, I can already tell that this is going to have one discontinuity. There's one x value that I can't plug in, otherwise I get an undefined value. And that is x equals negative 6. What happens if I plug in x equals negative 6? I get 3 over negative 6 plus 6, which is 3 over 0. That's an undefined value. So I should have some sort of discontinuity happening at negative 6. Well, look at some of these graphs. Look at A. A has a vertical asymptote, or an infinite discontinuity, at positive 6. Well, that's close, but that's not quite what we're looking for, right? We're looking for a discontinuity at negative 6. Notice B has the same thing, a discontinuity at positive 6. So I know both of those are out. Okay? And then if I look at C and D, sure enough, both of these have a discontinuity at negative 6. They both have a vertical asymptote at negative 6. Now, we just have to figure out which one is the one we want. Which one corresponds to our graph? Okay, which one corresponds to 3 over x plus 6? Well, the difference between these two graphs, they both have a discontinuity at negative 6, but the difference between these two graphs is for most of the graph that we see, D is positive, right? The graph is above the x-axis for most of the numbers we're used to. Specifically, an easy one to point out is 0, right? If I plugged in 0, it looks like I'm getting a positive number, as opposed to this graph where if you plug in 0, you're going to get a negative number. So that's how I can tell the difference between these two graphs. If I come back and look at my function, if I plug in 0, what do I get? Positive or negative? Since my numerator is positive, and my denominator is adding 6, right? If I plug in 0, I'm going to get 3 over 6, which is a positive value, right? And I can even do that work right here. If I plug in 0, I get 3 over 0 plus 6, which is equal to, it ends up simplifying to 1/2, but it's 3 over 6, which is 1/2. So I end up getting a positive value. So therefore, my correct selection is D. Can't be C because C, I have a negative value at 0 instead of a positive value. Okay. So I've now figured out which graph is the correct graph. And now that I have the graph, that makes these limits a lot easier to calculate. So let's check out these limits. First, it wants me to find the limit as x approaches negative 5 of g of x. Okay. Well, tell me about the function at negative 5. Negative 5 is right next to negative 6. So there's negative 5. My function has a valid y value. And my function's continuous there. So what is my function approaching? It's just approaching whatever this y value is. And what's that y value? 3. Okay. I can double check that by just plugging in negative 5 into my function. Right? If I calculate g of negative 5, I get 3 over negative 5 plus 6, which gives me 3 over positive 1, which is just 3. So sure enough, my limit for my function ends up just matching what the function value is. My function is approaching a y value of 3. What about as x approaches negative 6? Well, there's a reason why we're asking about this one. This is the discontinuity, right? This is where I have my discontinuity. And what type of discontinuity am I working with? I'm working with an infinite discontinuity where I have a vertical asymptote. But before you go and put infinity as your answer, or negative infinity as your answer, ask yourself the question, which one? Do I put positive infinity or negative infinity? The reason why you have to ask yourself that is because that depends on the direction you're coming from. If I come from the left, I'm going down to negative infinity. If I come from the right, I'm going up to positive infinity. So because the direction matters and it changes the value of my limit, if I don't specify a direction, the limit does not exist. So those are the two values for the two limits it has me calculate. This last limit doesn't exist because you have your limits on either side, your graph on either side approaches different values as I get close to -6. Okay, so the next example I'm going to go through is just the very next problem, number 16. And the reason why I want to go through this one is because this one doesn't give me a graph at all. It doesn't give me a graph to start with, and it doesn't give me a graph that I'm just supposed to select which one's the correct one. It just doesn't give me a graph. Instead, it gives me just a piecewise function. Why is this a piecewise function? Because you'll notice that the rule changes depending on what the x value is. So what this is saying is that for all x values less than or equal to 4, I use this rule. I use x plus 5 as my rule. But for all x values greater than 4, I use the rule 5x minus 16. Well, it turns out I don't necessarily need a graph. I can do this without a graph. Sure, a graph would make this easier, but I can do this without a graph. And here's how we're going to work through this. Let's start with this limit. The limit as x approaches 4 from the negative direction. Well, what does that mean? That means I want to use numbers. I want to use x values less than 4. I'm approaching from the left, so I'm approaching from numbers less than 4. That includes numbers like 3.5, 3.9, 3.99, right? I'm getting closer to 4 using values that are less than 4. Well, if that's the case, if I'm plugging in numbers like 3.5 and 3.9, which rule should I use? Well, that falls under this rule, right? Since x is less than or equal to 4, I'm going to use this rule x plus 5. So, if I plugged in numbers getting increasingly closer to 4 into number x plus 5, that function in itself is linear. It doesn't have a discontinuity at 4, right? So, all I need to do here is just plug in 4 to this function. I'm going to plug 4 in. Sorry, I should really use green because that's the function rule that we're using. Let's keep this color-coded. I'm going to plug 4 in to this function, x plus 5. I'm not plugging it into 5x minus 16 because that's the rule that I use if x is greater than 4. But since these numbers are less than 4, I'm going to use the rule x plus 5. And what do I get? I get the value of 9. So that's what my function's approaching as I approach 4 from the negative direction. Well, now let's look at the positive direction. Let's let x approach 4 from numbers bigger than 4. That includes numbers like 4.5, 4.1, 4.01, right? I'm getting closer to 4, but I'm using numbers that are bigger than 4. Well, now what's my limit? The difference here is if I'm using numbers bigger than 4, then now I have to use this rule, right? Since x is bigger than 4, I have to use the rule 5x minus 16. But once again, that's another linear function. It doesn't have any discontinuity, so I can expect it to act normally, right? It's not going to go to infinity or go to negative infinity. It's not going to jump. I can assume it's going to have just a normal behavior. So all I have to do is just plug in 4 into this function. And what do I get? 5 times 4 is 20. 20 minus 16 is 4. Okay. So my limit from the negative direction was equal to 9 because I was using the top rule. And then the limit from the positive direction ended up being 4 because I was using the bottom rule. Based off of those results, what's my limit if I don't specify a direction? my overall limit? Well, in this case, it doesn't exist. Why not? Because the limits from either direction were not equal, right? 9 did not equal 4. Since those were not the same, then the limit does not exist. Okay, good luck on the rest of the homework. If you are still struggling with the homework, please reach out. Come use the Zoom link for office hours or send me an email. But good luck with the rest of it, and we'll see you in the next video.